Okay, let's go about this problem. Solve 3 to power 2x plus 1 minus 3 to power x plus 1 minus 3 to power x plus 1 equals to 0. So we are given 3 to power 2x plus 1 minus 3 to power x plus 1 minus 3 to power x plus 1 equals to 0. And we are required to determine the value of x. This equation looks complicated because of its exponents. But on close analysis, we see a recurring term 3 to power x. To begin with, using the fundamental laws of indices, we must express every term in its simplest form. On applying the reverse product rule of indices, this equation becomes 3 to power 2x times 3 to power 1 minus 3 to power x times 3 to power 1 minus 3 to power x plus 1 equals to 0. Also, from the reverse power of a power rule of indices, this implies that 3 to power 2x is the same as 3 to power x but squared. This implies that this equation will become 3 into 3 to power x but squared minus 3 into 3 to power x minus 3 to power x plus 1 equals to 0. For simplicity, we should let 3 to power x equal to any variable of our choice. Let's use p. So let 3 to power x equal to p, which implies that this equation will become 3p squared minus 3p minus p plus 1 equals to 0, which is the same as 3p squared negative 3p minus p, the same as minus 4p plus 1 equals to 0. But this is of the form ax squared plus bx plus c equals to 0. It is a degree 2 equation, a quadratic equation. Let's use the bulldozer formula to obtain the values of p. From the bulldozer formula, x equals to negative b plus or minus root of b squared minus 4ac all over 2a. But on comparison of these two equations, this and this, we see that the coefficient of x squared, a, corresponds to 3, and the coefficient of x, b, corresponds to negative 4, whereas the constant c corresponds to 1, which implies that p will equal to negative into negative 4 plus or minus root of negative 4 by the whole of it squared minus 4 into a, which is 3, into c, which is 1, all over 2 into 3. From this step, let's use a calculator to obtain the values of p. So we go to mod, equation, degree 2, A equals to 3, in B equals to -4, C equals to 1. So our first value of P equals to 1, and the second value of P equals to a third. So either P, which is P1, equals to 1, or P, which is P2, equals to a third. For this problem, we are required to find the values of x, not P. But we did let P to equal to 3 to power x. So let's use this relationship to obtain the values of x. When P equals to 1, this implies that 3 to power x will equal to 1. But from the zero exponent rule, any number raised to a power of 0 equals to 1, which implies that 3 to power x equals to 3 raised to a power of 0. Thus, from the law of identity, x equals to 0. Also, when P equals to a third, it implies that 3 to power x equals to a third. But from the reverse negative exponent rule, a third equals to 3 to power -1, which implies that 3 to power x also equals to 3 to power -1. And still, from the identity law, x will equal to -1. But before we conclude, let's check for the validity of the obtained values of x. From the problem, 3 to power 2x plus 1 minus 3 to power x plus 1 minus 3 to power x plus 1 should equal to a 0. So for x equals to 0, let's substitute for x equals to 0 in this. We will have 3 to power 2 into 0 plus 1 minus 3 to power 0 plus 1 minus 3 to power 0 plus 1 equals to 0. This is the same as 2 times 0 is same as 0 plus 1. So we have 3 to power 1 minus 0 plus 1 is same as 1. 3 to power 1 minus 3 to power 0 is same as 1. So we have 1 plus 1 equals to 0. This cancels with this, so we remain with a 0 here. And this cancels with this, so we remain with a 0 on the left hand side, which should be equal to the 0 on the right hand side. Since the left hand side equals to the right hand side, therefore x indeed equals to 0. To save time, we can use the calculator to check for the validity of the obtained values of x. So let's feed in the left hand side of the problem into the calculator. So we have a calculator. We have 3 to power 2 alpha x plus 1 minus 3 to power alpha x plus 1 minus 3 to power alpha x to power x plus 1. This should give us a 0 for every valid value of x. So you go to cal, the value of x, we asked for the value of x. For this instance, it was 0. So we should get a 0. Also for x equals to -1, we press cal again. it asks for the value of x, which is -1. We get 0 again, which implies that if you input x equals to -1 in this, you will get a 0 on the left hand side, which should be equal to the 0 on the right hand side. Thus, x equals to -1 is also valid. Therefore, let's conclude. Therefore, x equals to 0 and also x equals to -1. This is the solution to our problem.